This is 6.3 volumes of revolution, number 47. So I've drawn a picture that they've given us, and the region, I've shaded the region that we're rotating, and this is going to rotate around the line y equals -2. So let me add more stuff for you. As I rotate this, this fuchsia line is going to rotate down to here, and that's going to produce a cylinder in the middle. Hopefully you can see. That's the hollow part. There's nothing there. But then I'm going to have a portion up here that's going to be, it's like a donut. You see the donut? See, it's solid, yummy donut on the outside here, hollow in the middle. Donut. So this might help you visualize and see. I'm going to reflect this down and do a dashed line. And this is the part that's getting rotated. Now, that might help you see it. And actually, I don't like the way I drew this. Make it a little better. Yeah. So hopefully you can, if that helps you see. I am going to do the whole thing, including the hollow middle of my donut. So I am going to attempt to draw a perfect disc. Yes, that is so beautiful. I have to figure out how to copy and paste that, because if I can copy and paste that, I will be a very happy camper. It wasn't quite perfect because it's kind of tilted, but I'm happy. I'll take it. So that is one of the discs on the outer edge. Let me do another one for the left edge. Yes, 2 for 2. 2 for 2. And that one's pretty straight. Can I copy and paste? Oh, duplicate. Oh, did you guys see that? I duplicated. That's what I need to do. I'm so happy. You know, that's what the frog said when he learned how to jump. I'm so happy. Okay, so you're going to have these discs starting here and working your way across. And that's going to get the volume, including the center. It's the whole football or whatever. So I'm going to find that volume first. So the volume is going to be pi r1 squared times the thickness, which is dx, and it's 0 to pi. How do I know 0 to pi? Because they told me 0 to pi. So I know it's from there to there. And that's going to give me the volume, including the hollow center. Then I need to subtract the hollow center. And I'm going to call that a different radius, radius 2. And we'll have to figure that out. But your radii always go from the axis of rotation to your graph. Well, my graph is, and your big R, another secret, will go from the axis to the furthest graph away. And the furthest graph is the blue one. So it's going to be from there to there to get your R1. And I will draw this. Let me see. I will do it in, not gold. I'll do fuchsia. Let me see this. Yeah, it's good. So it goes from your axis rotation to your furthest graph. That's going to be R1. And that's going to be big Y minus small y. So R1 will be big Y is the higher one, 2 sine x. Minus small y is this line here, which is -2. So I'm going to put -2. So that's going to be 2 sine x plus 2. And so I will place that for my first volume. OMG, I just realized something. I think you guys aren't going to be happy campers. 2 sine x plus 2. Unless I told you. I said no calc. I'm a jerk. Sorry. 2 sine x plus 2 squared dx minus. Okay, now we have to subtract the hollow center part. So I'm going to look at that. Let me get rid of all this R1 stuff. And I realize you're not going to, oh, and I'm not on, oh, I'm sad. I'm really messing up here. Gonna make a mess of everything. Okay. So let me shrink some stuff down. So now the inner circle is gonna be like this. Let me get rid of this one. And let me duplicate. That's the one I want. There we go. That's the hollow center. The hollow center is produced by rotating the x-axis around the axis of rotation, okay? Because the two curves that bounded your area was 2 sine x and the x-axis, which is y equals 0, as a reminder. So here is your R2. It goes from your axis of rotation to your graph, which is y equals 0. So that's going to be R2, which is going to be big Y minus small y, which is 0 minus -2, which is 2. So that seems pretty obvious if you look at it. Duh. What's the distance from here to here? It's 2. 2, because it goes from 0 to -2. It's 2. That distance is 2. So we could have done that without having to think big Y minus small y and all that. Okay, here's why I'm a jerk. Because technically you should know how to integrate this. But I realize you need an identity to do it. And I don't know if you remember the identity. So we're going to get pi. I'm going to square this thing. I'm going to get 4 sine squared x plus 8 sine x plus 4 dx minus pi integral 0 to pi of 4 dx. Now, I want to remind you this. You could have, try it again. You could have just found the volume of a cylinder with a radius of 2 with a length of pi and got the same answer. Instead of using integration, you could have just used your pi r squared h formula. All right, here is the problem. That's squared. What do you do with the squared? Does anyone know what to do with the squared? So we have a power reduction formula. Once upon a time, you learned this. And so let me show you this way, and then we will learn other secrets. So once upon a time, you learned that cosine squared x, that's going to be a long video, sorry, minus sine squared x equals cosine of 2x. Once upon a time, you learned that. So you want to figure out what sine squared is. So we want to get rid of the cosine squared. And once upon a time, you learned that cosine squared is equivalent to 1 minus sine squared x. And then you had this double angle identity that said 1 minus 2 sine squared x is cosine of 2x. And then you solve for sine squared x. I subtract 1 from both sides, and I get this. Then I divide both sides by -2, and I have this power reduction formula. And if I manipulate this with a little bit of algebra, I end up with 1/2 minus cosine 2x over 2. I believe that's that, and that's plus 1/2. So, wow, sorry, I apologize, because this is going to get really, really ugly. It's just going to get tedious, I should say. It's not hard, it's tedious. So that sine squared x, oh no, I solved for the wrong one. I was supposed to solve for sine, not cosine. Wait, I do have sine squared. Never mind. I'm okay. I'm okay. I'm freaking out here. So sine squared x can be replaced with this. So I'm going to replace that with 1/2 minus cosine 2x over 2. Plus 8 sine x plus 4 dx. And then I'm just going to do this. That's going to come out to be what? Well, I could figure that out. What's the area of that? It's going to be pi r squared. So r is 2, 4 pi times pi, 4 pi squared. I'm hoping this answer comes out right, because if it doesn't, I don't want to go back and figure out where I made my mistake. All right, let's keep going, because this is so fun, right? We're going to distribute the 4, and we're going to get 2 minus 2 cosine 2x plus 8 sine x plus 4. But let me combine this 2 and that 4 and just make that a 6. It's going to make my life easier. Dx minus 4 pi squared. All right, now we have to find the antiderivative. Okay, we need to do a u sub. I told you it's going to get ugly. Let me break this up into different parts. Minus 2 cosine 2x dx plus, and then all of this I'm going to do as a separate integral. Minus 4 pi. Please, please, please have the answer come out right. I don't want to backtrack. Here we go. This problem has so much potential for error. Any tiny little mistake anywhere. And hopefully if I find one, you would tell me before I proceed on. Okay, I need to use sub. I'm going to let u be 2x because I want a single variable here. I don't want 2x. That's going to make du 2 dx. You know what's awesome? Check this out. I have 2 dx. That is beautiful. So what is that going to do for me? That is going to allow me to rewrite this. And I'm already concerned. Oh, maybe not. I think we're okay. Negative cosine u du. Oh, who caught my mistake? Everything has to be changed to u's. That's x, that's x, that's x, that's x. I changed that to u. I changed all this to du. I need to change these to u. And it's going to be 0 and 2 pi. Why 2 pi? Just to remind you, plug in pi for x, and u becomes 2 pi. And let's do this. The derivative of what is 8 sine x? It's going to be minus 8 cosine x plus pi 6x from 0 to pi minus 4 pi squared. I hope this comes out right. I will be so excited if it does. I will be very, very excited. All right, let's keep going. The antiderivative of minus cosine is minus sine u. plus, we can start plugging things in. Pi times -8 cosine pi plus, oh man, I am running out of room. I should have written smaller. I'm going to write smaller because I am quickly running out of room. Pi times -8 cosine pi plus pi 6 times pi minus, I plug in 0. Uh-oh. Pi -8 cosine 0, and then that's going to be 0 minus 4 pi squared. Let's keep going. I apologize for not making this a calculator problem. This is so long. So long. I'm going to get pi minus sine of 2 pi minus sine of 0. Ooh, I think that's all going to be 0. I think that's 0. I like that. Minus or plus. And then cosine of pi is -1. Cosine of pi is -1. So that's going to get us positive 8 pi plus, oh, it's going to get pi squared times 6 minus, and then cosine of 0 is 1. So it's going to be minus -8 pi minus 4 pi squared. Whew, I am so close. That's 0, that's 0. I get 8 pi plus 6 pi squared plus 8 pi minus 4 pi squared, which is 16 pi plus 2 pi squared. Is that the answer? Please, please, please. Oh, I got to factor 2 pi out. I got to factor 2 pi. 2 pi, that's 8 plus pi. Is it 2 pi, 8 plus pi? OMG! You do not realize how happy I am right now. That was so long, and I got it right.